So finally we are doing this. This is the first Flutter meetup and the 7th React Native meetup. Okay, going forward, let me introduce myself. I am Sanket. I'm a co-founder here at GeekyAnts, and I go by the Twitter handle Sanket Sahu. So you can go ahead and follow me. And this, yes, the most important thing. You guys can get connected to Wi-Fi. This is the password. So if you want, go ahead. It's GeekyAnts9 with G and A capital. All right. Yes. So as I said, this is the 7th React Native meetup. We have done it quite a few times. Uh, Earlier, we have done it at GeekyAnts and also at a couple of other places here in Bangalore. And this is a community event. It's just that it's hosted by GeekyAnts and nothing like we are like promoting our own stuff. So it's like a community event. And yes, uh, first Flutter meetup. Uh, we were a little confused where to actually do it because Flutter and React Native, they are somewhat related, and we didn't even have many people in the Flutter meetup group. So I thought, okay, this is a good time for the Flutter enthusiasts and also those who are actually promoting Flutter to use it, I mean to not use it, but actually to get together and talk to other people who are doing React Native and see how we can actually collaborate and learn from each other. So I think it's the perfect combination, React Native and Flutter. And yeah, we are pretty active in conferences too. Uh, we do JavaScript meetups and conferences. We actually attended Chain React just last week. Before that, we attended React Native Europe and React Europe. And here in Bangalore, we have been doing JS Channel, JS Foo. We are actively involved with the people of JS Foo and React Foo, trying to collaborate with them and help them with the latest stuff of JavaScript. And yeah, we are pretty much famous with, not famous, but yeah, we are pretty much known for our contribution in React and React Native community. And the first one obviously is Native Base. Native Base is a UI component library for React Native. So there's a bit of history actually, how we started with Native Base, how actually we were experimenting with React Native and thought, okay, we should contribute to React Native community with something like a UI component library. So we came up with this idea, and yeah, we are about to reach 10,000 GitHub stars, which is we are proud of. And we also created a little bit of marketplace for the developers who are willing to actually make a little bit of money with that, so they can actually host, publish their apps, and there are you can even buy actually the themes which is available there. We call it Native Base Market, which is a one-stop solution for React Native Marketplace. And this is one of the products which we have been working from past, I think 1.5 years now. So this is called Builder X, and it's a screen design tool, which is similar to Sketch, but the catch is it actually codes for you. So using this, you can actually design screens as a designer, and it actually behind the scene codes for you. So the data format for this tool is actually .js file at the moment, and we are going to add even Google's Flutter here. So as a designer, you can go ahead and design stuff like design header, footer, and all the UI widgets. And behind the scene, it actually writes React Native at the moment, and in the future, Flutter is also coming. And we have also worked a bit on Vue. We have contributed with our library called Vue Native. So we know that React and React Native are like brothers. So with Vue, we didn't have anything like Vue Native. So we thought, okay, let's try to build Vue Native. So with the same knowledge of Vue.js, you can actually build mobile apps. And we actually didn't build this from scratch, but this is somewhat like a hack. So it actually converts your .vue files into React Native files. And you can use the goodness of both the worlds. Like with Vue.js, you have a very nice observable pattern for the data management. You have a very nice way of declarative template engine and all those things. So you can actually use both the things, a bit of React Native and Vue.js. We call it Vue Native, and we were trending at #1 on GitHub for this for almost a day, which we really, I mean, that was one of the moment for us. And yeah, 4,000 stars on GitHub, open source. Go ahead and try it out. And yes, we started with Flutter. last year in July, when me and Atul went to Chain React in Portland, we were lucky to actually speak to Seth Ladd and Yogar from Flutter team, and we spoke to them, and they told us about like how good Flutter is and what we can do. I won't say we actually compared React with React Native, but yeah, the good things about Flutter, we actually got moved. We thought, okay, we should try it out. And that's when we started experimenting with Flutter. And yes, we also met Wim Leeler at London at a conference of Google. Those three people are Pramada, Ashwati, and Madhushri. And we had a fun time there. And we also contributed to open source in the Flutter community with animations like this. This got a lot of retweets on Twitter. And we built many apps like live location sharing app. Ankur also built a news app, which was very similar to, I think, Reddit, you can say. And yeah, so those apps. And yes, this was actually a very good thing for us. Since we came from the React Native background, we thought, okay, we could help the people at Google or the Flutter team to write a part of their documentation which helps React Native developers to try Flutter. So we wrote an official part of the documentation which says Flutter for React Native developers. So we have code snippets available for Flutter there, which actually also has the equivalent code in React Native. So you can actually one-to-one compare the code and learn from there. And yes, since we had native base and React Native market, we also launched Flutter market. We have quite 4 or 5 themes available there. You can go ahead and download it. And yes, so time to have a Flutter and React Native meetup. We have 4 speakers today. The first one is Shakti Shri. She is a software engineer at GeekyAnts. She'll be talking about advanced React patterns. And the second one is by Rohan Taneja. He'll be talking about why you should try Flutter, why there is a place for Flutter in this ecosystem. And Rohan is also going to join GeekyAnts from Monday, which I'm really excited about. And then we have a break. After that, we'll have Wim talking about why you should try Flutter. And he'll give a detailed overview of like the architecture of Flutter, I guess, and all those things. Then we have the fourth speaker. This is a GraphQL talk. So he works at a company, he's a co-founder at a company called Hasura, and they are building a very nice tool called Hasura again, which is actually a GraphQL as a service backend. So I think he's not here yet, but I think he'll be coming in some time. So yeah, let's get started. Let's I think, yeah, and one more announcement. We have GraphQL meetup on 11th August happening here. So you can join that as well. And you can tweet about this meetup with hashtag RNBLR and FlutterBLR. All right, so let's give a huge round of applause for Shakti Shri for the first talk. Dash.
Hello everyone, I'm Shakti. I'm working as a software engineer at GeekyAnts, and today I'll be talking about advanced React component patterns. Why do we even need these advanced React component patterns, right? That's very important to know before proceeding. Uh, in the process of developing any application, we try to make components as flexible as possible, as reusable as possible, right? So if there is any additional functionality to be added in the middle of the process, the component that exists shouldn't expect us to make more number of changes. With the minimum number of changes, I should be able to add the additional functionalities. And we might face various problems through the way of development. So we have these React component patterns available which can solve all these problems for us. So let's just go through all of these patterns and learn the concepts. Okay, before going through the concept, let's look into the simple example. It's a simple toggle component example. Here you can see we have a user component and a toggle component. Right, the user component is utilizing the toggle component, and in user component we have a switch and the text that is being rendered. The text is on when the switch is on and off when the switch is off, and whenever the switch is being clicked, the toggle method will be triggered, which is in turn changing the state value of toggle component and also calling a callback function on toggle in order to inform the container about the change in state of switch, right? So this will be the output of our simple example. So we'll be implementing all our concepts, patterns in this example and learn the concepts, right? So okay, consider this scenario wherein my application has 4 different screens, and each of these screens have different configuration of the toggle component being used. So you can see the children elements of toggle component is being aligned based on the requirement of different screens. So I will have to make my toggle component as flexible as possible to support all of these configurations. How can I make it? The simplest solution that I can think of is sending a prop, a control prop which specifies which configuration is required, and based on the prop that is being received, the toggle component may conditionally align the children elements or render the children elements based on the condition, right? That's the simplest question, simplest solution. But however, now we just have 3 children element, maximum of 3 children elements available here, and it is pretty okay. It is okay to use props here. It wouldn't be a burden. But what if I have like 10 or 20 children props of children elements available in toggle component? It would be difficult for me for the toggle component to uh, 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 align these children elements based on the configuration. It would be conditionally rendering these elements would be pretty difficult. So prop doesn't seem to be a reliable solution in this case. So let's look into the next solution. The next solution would be compound component pattern. Right, so here this particular pattern, it actually provides each of the child element to the container separately. What I mean to say is, we have 3 elements here, on, switch and off text. So all of these are provided separately to the container, so that the responsibility of choosing and rendering, aligning these child element goes to the container, that is user component, right? So let's look into the implementation part of it. So here in the toggle component, we are render part of the toggle component, we just are rendering the children that is being nested inside it, and in here we have 3 different static compound components available, on, off and button, and we are actually accessing those compound components as class name dot compound component name. So toggle dot button, toggle dot off and toggle dot on will be 3 different compound components available to my container. So I can now align the children elements as per my requirement in different screens. But if you can see here again, it's the text that is being rendered on different states of switch is hard coded. So let's just make it more flexible, so that I can have a image being rendered based on the state of the switch, right? So all we need to do is again nest the component or element that we want to render inside those compound components and render the children in the compound components, right? So now we could make our toggle component flexible enough to align the children elements as per the requirement in different screens. And moreover, the solution is also simple. It's not that we need to maintain the configuration prop at the container, and the toggle component need not know about different configurations that are being used, that are being expected from the component. So it's a simple solution. So yeah, I can align the children elements as per my requirement now. Okay, so we could solve that problem. If you can see here in the second image, I have wrapped one of the compound component inside a wrapper, a div, to provide a styling. There might be a requirement in our applications wherein you want to combine the compound component with another element, and such requirements. So here you can see I have wrapped the toggle component, toggle.button component inside a div. What do you think will happen now in this implementation? Will I get the error? Will I get the error, or will I be able to get what I have expected? Anybody? Yeah, exactly. So if we carefully look at the render part of toggle component, we are just rendering the children elements, and we are cloning the children elements, and in the process of cloning, we are also specifying the values that is to be sent to the children element. So here, now the children elements of toggle would be a div, toggle.off and toggle.on, right? So the values that we are sending here will be sent to div and not to toggle.button, because we are not manually passing down the values to toggle.button. So if whenever we are nesting the compound components this way, we should be careful to handle the error as well. So how can we solve this problem? We cannot expect the user to use it in an inappropriate way, right? So we have React Context API available in order to solve this problem. It actually uses provider consumer pattern to solve the problem. We can actually send the values directly from provider to the consumer. So if you can see here in the toggle component, we have a provider. We are actually rendering the children elements of toggle are available as prop in my toggle component, and we are wrapping it up with the provider, right? And if you can see here, we also have the value being passed. On is the state value of switch, and toggle is the method that is triggered each time the switch is being lit. And we are wrapping up each and every compound component with the consumer. So now from the provider, the values are directly being passed to the consumer. So we need not worry on how nested the compound components are. The values are anyway directly passed, right? So React Context API is very helpful that way. Then again, there are chances that you see, when we are working in a project, we work in a team. One developer might develop a component and the other developer might reuse the component, and he might not know the actual implementation of the component, right? So he might use it in the way he wants. So here the whole compound component is, all of the compound components are being wrapped inside a div and not inside toggle component. So what will happen now? Obviously I end up with an error, right? Because I am not providing, I'm not basically providing the values. It's not being wrapped up by a provider to for the values. So I get an error saying that on is not a variable, on is undefined, toggle is not a function, and all that, right? So it becomes very important for us to handle all these error cases. So let's have a validator function that can validate if the context is actually available, if the values are actually available, right? So here we have toggle consumer function which actually validates if the context is available. So in this case, the context is not available. Here you can see it's actually conditionally rendering either an error or the component. So if there is no context available, then I get this message saying that compound components are outside the provider. So now I get an idea as to how the component is being implemented internally, right? I get to know that React Context API is being used, and I'm not using the compound components inside the provider. So I change my code accordingly. So it becomes very important to handle various error cases as well. Okay, so this is the previous example, React Context API example that we just saw. And if you can see, each and every compound component is being wrapped up by the consumer. And isn't it too redundant that we are again and again wrapping each and every component with the consumer? So rather than redundantly wrapping it up, we can have one single function that accepts the internal component, that accepts the compound component and wraps it up with the wrapper and returns it back. So that particular function is called as higher order component, right? So here we have a wrapper function, which is a higher order component. It is actually accepting a component and prop to be sent to the that is to be sent to the component as an argument, and it is wrapping it up with the consumer, and it is returning the wrapped component to us. And here in the static feeds, we are just calling that particular method with necessary arguments, right? So now we are able to reuse the code. We are not redundantly using the same code everywhere. We are able to reuse the code. So actually before ES6 syntax was introduced, we were using mixins to reuse the code. But once ES6 format was introduced in React, mixins were no more supported. So we had to find some other way to reuse the code, and HOC was the first solution that we could find. So yeah. Okay, let's consider another use case. You can see I have 4 different screens, and I have 4 different types of toggle component being rendered. It's not the same component that I'm rendering in all of these screens, but it is the same functionality that all of these components use, right? So all we want to do now is reuse the functionality and not the UI part of it. So how can we do this? Again, HOC can help us through this way. Yeah, so if you can see here, I have a user component which is actually rendering which is handling the render part of it. It is displaying, it is rendering a div and a switch, and we are wrapping the user component with the toggle component. What is toggle? Toggle is an HOC. You can see here. Toggle is an higher order component which is actually accepting a component as argument, and it is basically providing all the values, necessary values to that component, and it is returning back that particular component. So internally what is happening here is when I render it this way, internally the React component will first make a copy of it, a clone of it, using React.clone API, and then render the clone part. So the reference of the component, the reference of this component and the reference of component that is being rendered will not be same, right? So that's one of the disadvantage of higher order components. And moreover, the way we implement higher order components, it's a static composition. We cannot change anything, the composition dynamically. That's another disadvantage of higher order components. And moreover, the props that are being sent from the toggle component, the toggle higher order components must, the containers must be well aware of various props that it may use. You see, that must be specified in the documentation properly, right? So these are some of the disadvantages of higher order components. So let's look into the better example which can solve all of these, which can overcome all of the disadvantages of higher order components. So that's render prop. This is yet another pattern in React which can overcome all the disadvantages of higher order components. So let's look into the implementation part of it. So here in the toggle component, we are just rendering the children, right? We are just rendering the children that's been nested inside the toggle, and here at the user we have nested down the components that we want to render inside toggle, and you can observe here the state values of toggle component are available here for me at the user component, right? How is this possible? Usually when you want to share the data from child component to parent component, what is the normal way? It's callback function, right? We send the values from child element to the parent element through callback functions. Here render prop is actually helping us through the way, and we are able to send the values, the state values from toggle component to the container component. So yeah, this is not a static composition. Yeah, it's a declarative way of implementing things. So it's solving all the problems that we had with HOC, right? So again, there is one another thing to concentrate. The whole render part is actually handled by the container, and only the functionality is being implemented at my toggle component. So we are basically able to reuse the functionality. Okay. So we could handle the render part of it, but it becomes necessary sometimes for us to gain more control on state of toggle component. You know, like when I have a screen, and when I open the screen, I want the value of a switch to be on initially. So for that purpose, I want to gain control on the initial value of the state, right? How can we do that? The first and the simplest solution is using control prop. Simple. It's the toggle component will be a dump component, and the user, the container component, will send the prop, send the value, and the switch in the toggle component will work based on prop. So this is one of the patterns, simplest pattern that we might have come across. The next pattern is state initializer pattern. We basically use it when we want to gain control over state of toggle in render prop pattern, right? We'll be using it along with the render prop pattern. And here, if you can see, along with on toggle callback function, we are also sending the initial value of the state as a prop. So this particular value will be initialized to the state, right? So it's also important to have a default value whenever we are using state initializers. Otherwise, if the user is not providing the initial state prop, then we might end up with an error. So yeah, it's better to have a default value for state, right? So this is all about state initializers. Okay, so there is another, there are three different requirements for me now. Let's look into the first one. The first one is an additional reset functionality. So I want a button at toggle component, and whenever I press on this button, I want the value of the switch to be the initial value of it, right? It should go back to its initial state. That's the first solution. How can we solve this? Again, by using callback function, right? We can have the way we have on toggle method, we can have on reset callback function being called each time the button is being pressed. Let's look into the second functionality requirement. So here I'm tracking the number of times this switch is being clicked. If it is more than 4, if I'm clicking the switch more than 4 times, then I should disable the switch, and until and unless the reset button is pressed, it shouldn't be enabled, right? That's my second additional functionality. So how can we solve this? Again, we can have a counter in toggle component that gets incremented on each time the switch is being clicked. Then we can send that particular counter as an argument to on reset method, right? We can solve it that way. Okay, let's look into the third functionality. So this particular input box is in the container component, and switch is in toggle component. I want to control the value of switch with the value that is being entered inside the input box. So if the value inside the input box is on, the switch should be on, and if the value inside the input box is off, then the switch should be off. So again, we can control this by using simple prop, right? This is a pretty simple example, and we can achieve, we can solve all the problems using just a prop. But what if I have a complex component? It would be difficult to have, if I have like 10 events to be monitored, then I will have to send 10 callback function as a prop, and again maintaining those callback functions is a burden to both toggle component and a container component, right? So the better solution would be state reducers. If you have ever worked on Redux, you'll be familiar with reducers, right? So when does the reducer function, where a reducer method gets executed? Anybody? Sorry? Exactly. So each time we trigger some action, the corresponding reducer will get executed. And what does it do? The reducer, what does it do? Exactly. So it manipulates the state. So here as well, we have a reducer that manipulates the state based on the change that is being triggered, right? Let's look into the implementation. So we have toggle state reducer method that is being sent as a prop to toggle component. So what is this particular reducer accepting? It's accepting the current state, and it is accepting the change that is being triggered. And based on the change that is being triggered, it is manipulating the state and it is returning back the state. So let's look into toggle component as to how this particular method is being handled. So whenever there is an state change event, so I'll be calling state reducer. You can see here the internal set state, and in internal set state I'm calling the state reducer, and to the state reducer I'm passing the current state values and the change object. Change object is the change that is being triggered, right? And here whatever the manipulated state that is returned by the reducer will be assigned to the state in toggle component. So we could achieve three main things here. One, I could avoid unnecessary callback functions and all those burden to maintain those callback functions. Two, I could track all of the events that are going on inside the toggle component. And three, this is the biggest advantage of state reducers. I can choose to either completely expose my state or partially expose the state, in the sense that I might be using a loader variable inside my toggle state, right, which doesn't make sense. If the loader value is changing in toggle, it wouldn't make sense for the container component to know about it, right? So in that case, I might choose not to expose the change, not to inform the container about the change. So yeah, so state reducer is one of this good pattern which provides me a better control over the state. Yeah, so we could see how how different patterns could be used with each other parallelly, or and like in router, React router, we can see that if you have ever used React router, we have with router wrapper. That is actually a combination of HOC and render prop, if you look at the implementation. So this way we have various open source projects that are using these patterns, and they make the implementation simpler and maintainable. So yeah, do try these patterns once. And if this talk was mainly based on Kenzie Dot's talk in Egghead, so do go through those tutorials if you want to gain deep knowledge about these patterns. And he has also explained about various other patterns too. Any questions? Not really sure.
Yeah, so these are actually just patterns. These are not something like features which comes with React. So you can use these patterns in the, I mean, very old versions of React as well. It's not something with the new version. Yeah, context API is pretty new, but other patterns like HOCs or render props, those are pretty old ones. Yeah. More questions? Official documentation for this?
Yes, yes, you have the official documentation in React itself. Yeah, yeah, React documentation. You do get all these
So I think
information.
it's partially available. Like
About
something like context API and those things are available in the documentation, but patterns like render props and all those things are a mix. I mean, it's available partly in the talks of different people, like Ken C. Dodd's talk and Dan Abramov's talk. So you can actually fetch it from there. Yeah. All right, I think in a very short time, Shakti covered a lot of different patterns and features. So I think she just scratched the surface, and that's good about meetups and conferences. You just give the keyword, and people can go back and then research about it and learn more. Yeah, thanks a lot, Shakti. Yeah.
thank you.
All right, it's almost a full house. When we started, it was like 70, 60%. So it's good to see so many people. All right, you can give it here. So we are I think not more than 50 or 60 people. We can keep the questions and we can keep the session a bit more interactive if you guys want. Maybe Rohan, if you want more questions from people or interact with them, that would be great. Okay, so let's welcome Rohan for the next talk. Yeah, you can set it up. So this talk is about Flutter, and that's what we are doing. We are mixing. Whoa. Okay. So yeah, all set. Okay, all the best.
Hello. Yeah. So hi everyone. Just as Sanket said, I'll be talking about Flutter. And before I start off, may I please have a show of hands how many people have already used Flutter? Okay, great. And how many of you are pro React Native developers? Yeah. Okay, this would be fun. All right. So my name is Rohan Taneja. I'm an Android developer for a days on GeekyAnts, and I'm an organizer at GDG New Delhi. So I'm a native Android developer, or as we call it, OEM Android developer, since Flutter is native as well, so don't confuse those terms. I'm an OEM Android developer who recently fell in love with Flutter. So I'm here to share my excitement with you and to try and convince you to try Flutter just once. Try it for a day and then let's see what happens. I'm not here to tell you that Flutter is the best SDK, that would be ridiculous. Let's see. So those of you who are pro React Native developers are probably shaking their head that they're never going to leave React Native no matter which SDK comes to the market. So hold on for 30 minutes, I may change that thought. So my title, the title I chose is that why Flutter is the framework developers deserve and also the one that they need right now. A Batmanist title just for the fun. So I'll be focusing on the second part first, but also the one that they need right now. So what's so special about right now? Recently, Google announced that Android is running on 1 billion active devices. Shortly after that, Apple came out with the announcement that iOS is running on 1 billion active devices. So if you're only building for Android, you're losing out on a potential revenue of 33.3%. If you're only building for iOS, you're losing out on 66.6%. Basic math. Other than that, cross-platform framework, using those frameworks allows you to develop your apps in using half the effort and half the time. So let's say you're sold on the idea of cross-platform framework. Since most of your React Native devs over here, you already are sold on that. But what about Flutter? So let's just leave aside Flutter for a little while. Let's focus on cross-platform frameworks. The first one that caught the most attention was probably the Ionic framework used by Amazon, and that's why you see the 404 error page a lot. So the Ionic framework uses a web view. Everything that you see on a screen is typically a web view, and everything is displayed inside that. Another problem with the Ionic framework is that it uses a bridge to access your native sensors or your OEM sensors like location, audio, and camera. Then this thing came to the market and it dominated the whole mobile app industry. So React Native solved the problem by getting rid of the web view and replacing that with a JavaScript bridge that allow you to access your OEM widgets from Android and iOS. So you have your JavaScript bridge that accesses your native Android and native iOS, and that is displayed on your app. It also allows you to access your location sensors, audio sensors, and all that stuff using the JavaScript bridge itself. But since we are talking about OEM widgets, let's just consider OEM Android and iOS as well. Pretty simple structure. You have a native code, they access OEM widgets, it gets displayed on your screen using the canvas, and you have direct access to location, audio, and camera. But before we head into Flutter, let's just take a moment back and think that how does an app really come into life? So if you're an agency like GeekyAnts, there's a client who comes to you, he tells you their idea. Then the client sits with the pre-sales team, the business analyst, and the designer, and the client tells the designer what he's thinking about. The designer takes a couple of weeks, comes out with brilliant UI and UX, and creates a mock-up. Then the designer, which is on the left of your screen, to the developer who's on the right of your screen. Sorry for the cliche image, but that's all I could find. So the designer tells the developer that this is what I have designed. Would you be able to do this? And what do we say to our designers? We say no. Because the ideas, brilliant ideas that they have are really difficult to implement. In your head, they look amazing, but when you try to implement them, they look really tough. So after you say no to your designer, you do either of two things. You either doze off, or you start celebrating, feeling that you've done a tremendous job by refusing to do the job to your designer, and now you can finally relax. But there are some people in every company who can never see happy developers. That's where this guy with his ever diplomatic face and approach steps in. He says, so the product manager says that the management has approved these designs and you, the developer, would have to work on them. So he asks you a simple question, when can this be done? And we as developers, what do we say to a product manager? Not today. So then you sit down with the product manager, you give him a realistic timeline, which gets immediately cut into half, and then you have to anyway implement those designs. But that makes you wonder. So the problem with saying no to designers is that there are some problems that developers have been solving for far too long. Some trivial problems. If you're an Android developer like me, having custom fonts in your text view is a huge problem if you're a beginner. Trying to implement basic animations is a problem itself. Then when you finally get to know about activities, you learn about fragments and a thing called the backstack. So that's an issue as well. Even if you get over all these problems, there are some problems that go back to API 14, API 16, and device-specific problems that are really a big concern. I'm sure you must have heard about the Samsung Galaxy S4 camera issue. It's never working. So the problem is that even if you put in your hours, you put in your weeks, you get down into these problems and you solve them. The worst part is that they do not provide any business value. You're solving these problems only because they are a problem with your platform. They do not put money into your client's pocket. So they add no business value. So that really makes you wonder, does a mobile developer's life need to be that tough? Does it need to be that hard? Shouldn't developers instead be focusing on writing better maintainable code, scalable architecture, or trying to implement features that actually add some business value? That's where Flutter steps in. So I'll be talking about Flutter now and how it's helping you solve all those problems. So what's so special about Flutter? So Flutter is Google's mobile SDK for building beautiful native apps in record time. Two key focus areas over here. Number one, building beautiful native apps. Number two, in record time. So let's start with the second part again, in record time. So how is Flutter able to build apps in record time? Point number one, Flutter uses Dart. So all those of you just like me who thought that Flutter was dead, it's not. It's one of the most used languages internally at Google. And now that Flutter is out, it's one of the most popular languages in the external developer world as well. So the thing that's special about Dart is that it can be both used as a compile time language and an interpreted language. A compile language is your Java or Kotlin that's first compiled and then shipped. Your interpreted languages is JavaScript or Python that's shipped and then compiled on the fly. So Dart can be used both. So before we step into the details of Dart, let's just talk about an experiment that the Dart team at Google conducted. So the Dart team wanted to get some feedback on Dart and Flutter. So they went to another development team in Google itself. They told them what Flutter is, but they did not tell them what language they'll be using to build Flutter apps. They told them what Flutter is, they asked them to build a few features, and the next day when the Dart team went back to the other team was building features on the fly. Then the Dart team asked the other team that, do you know what language you're using? We haven't provided any documentation to you at all. The other team said that this language was so easy to pick up that they didn't need any documentation at all. if you are from a Java or a JavaScript background, taking up Dart is the easiest thing. If you want to learn Flutter directly. Don't go into learning Dart. So next, Dart allows you to have an amazing feature that's called the stateful hot reload, similar to what you have in React Native. So for Android developers, think of stateful hot reload as instant run, except for two things. Stateful hot reload actually works, and stateful hot reload is amazingly fast. It would be a crime to compare its speed with the speed of instant run in Android. So I say stateful hot reload. By stateful, I mean that if you are 10 screens down into your app and you make a change over there, you won't have to go to the first screen, come back to the 10th screen and see if the change was reflected. It's reflected within seconds. And that's done because Flutter separates the UI from the state, just like in React Native. So why Dart special in this case? Because this can be achieved only because Dart offers just-in-time compilation. That's why you have stateful hot reload. So it's so quick that something like a chat application, which most native developers dread, can be built in a matter of 5 to 6 hours. So this was the first project that I built as a Flutter developer, and I did this by referring to a Google Code Lab itself. So if you're not stupid like me, you don't make mistakes even when you're referring to tutorials, you can easily do this in 3 to 4 hours. So note that this app is using Firebase real-time database. So Flutter has amazing support for Firebase as well. And also note that the toolbar is different on Android and the toolbar is different for iOS. So you can easily make changes that are platform specific, even if you're using a cross-platform framework like Flutter. Moving on, everything is a widget in Flutter and the whole widget tree is drawn on the screen at runtime. So what does this mean? What does drawn on the screen at runtime really mean? So this is what Flutter structure look like. You see an engine at the bottom that's entirely coded in C++, and you see a framework that's entirely in Dart. A couple of key things over here. The engine contains a Skia graphics engine that's responsible for allowing you to have all those renderers in your app. Then the render on the top displays your widget on the canvas itself. So this means that Flutter is not using your OEM widgets. It's not using your text view from Android. It's not using the corresponding thing from iOS. It's drawing everything on the screen at runtime thanks to that Skia engine and the renderer. Another thing that if it's not using OEM widgets, then how is a Flutter app native? A Flutter app's native because of the amazing language that it's using, that's Dart. Dart allows just-in-time compilation, but it also allows ahead-of-time compilation. That allows you to compile your code directly into native ARM code. And that's how you get a high-quality native apps that promise to deliver 60 FPS animations as well. Something that React Native is still struggling with a little. So now you wonder, I have a recycler view in Android that offers me amazing recycling properties. My view is smooth enough, but how do I get that in Flutter if that's not using my native views? So Flutter has recycling embedded in the system itself. You have a list view in Android that does not have recycling. You have a list view in Flutter. You have a recycling view in Android that has that recycling part. You have a list view builder in Flutter that has that recycling part. So every view that you have in Android or iOS, there's a corresponding widget for that by default. So this is what Flutter structure looks like. You have a native code thanks to the direct compilation to ARM code. Then there are widgets that are directly rendered onto your canvas. Note that there's no web view over here, there's no JavaScript bridge. Even for accessing platform-specific channels like location and audio, you have no bridge at all. So yeah, so when compared to Ionic, Flutter does not have a web view. When compared to React Native, there's no JS-like. When compared to Java, Dart does not use a virtual machine. And when compared to other frameworks, Flutter does not use OEM widgets at all. So there's a star in front of no virtual machine. That's because when you run your Flutter app in debug mode, there's a banner on the right top that says debug. That's when Dart is really using a virtual machine. If you take out a release version of your app, the virtual machine is no longer used. The virtual machine is only required so that you can have stateful hot reload. So if you have a release app, that would be much smoother than your debug version. So let's consider a scenario where you have a client and you're working in an agency and he wants you to build a chat app that looks like WhatsApp. So this is what you give to him. Pretty amazing, you did the job, that's fine. But the client is from, let's say, US, Australia. All he sees the whole day is people carrying iOS devices. He knows what iOS UI looks like, but he has no clue about Android. So he asks you to build something like this. You want the iOS UI replicated on your Android device. Now doing something like this is really tough with React Native and is amazingly tough with Android and iOS. But Flutter can get this done easily because it is not using your native views. Anything you draw on the screen, you can draw it on iPhone or an Android device. So that's why you can easily achieve this. Similarly, you can also have material design running on iOS device itself. Not the best thing to do, but this allows you to do an amazing thing. So if you have a Jelly Bean device that came out in 2012, material design came out in 2014. If you want to run material design on a Jelly Bean device, you can do that with Flutter, not with any other platform or framework. Because Flutter is drawing everything on the screen, you give it Jelly Bean, Lollipop, Marshmallow, it will draw the same thing on the screen. So these are some award-winning apps. These apps won the Webby Awards for the best UI and the UX. If you look closely, there's the Android version on the left, the iOS version on the right. These two versions look extremely similar, probably 90 to 95%. There are some key changes in both of them, and they are really crucial. So these are not Flutter apps. These were built using OEM Android iOS. But if you want to build something like this with Flutter, it would be extremely easy. You'll just exactly code once, and you'll have the same thing replicated on both of them. There are some other apps as well. You can see that the brand integration is taken into account as well. There's no issue that whenever you're using material design, all your apps start looking like Google apps. So there's none of those issues with Flutter. So let's move on to another story. There's this huge MNC that builds Android phones. And one day they feel that they are not doing so well with sales. So they call a meeting for their top management. And everyone in that meeting is proposing ideas. The first person says that let's have slimmer phones. The second person says, let's offer better battery. Third person says that, why don't we just have a dual front camera? Then this genius steps in, probably the design head. He says, why don't we just override all system fonts? And this is what your app starts to look like. I'm pretty sure you must have figured out which company manufacturer I'm talking about. But if you are using this phone, if you have been using this phone, you know how ugly it looked at times, especially in apps like WhatsApp, Instagram, Facebook, most highly used apps. So no matter what you do, no matter if you choose React Native or Android, you cannot override this. But you can override this in Flutter because override all system fonts you want, will not be using them. Flutter is painting directly everything on the screen. So Flutter also allows you to leverage your existing knowledge. If you're a pro Android developer who knows all the shortcuts for Android Studio, or you're an iOS developer who loves Xcode, or if you're a React Native developer who's been doing everything with VS Code, you can build your Flutter app using these IDEs itself. You just need the Flutter plugin. So you don't need to get access to another IDE. There's no special IDE for Flutter. You can use any of these and you can get your app running in minutes. Flutter also has amazing support for Firebase, just as I discussed earlier. It offers amazing support for material design. And the key thing over here is that you can still access Android APIs, iOS APIs, and SDKs for both of them as well. So Flutter has support for those as well. So Google conducted another experiment. They were using an Android app internally and they wanted to build the iOS client for that app. So that was their requirement. Instead of building the iOS client using Swift and Xcode, they decided to build a Flutter app and they shipped it to both platforms. The best thing was that the existing Android users could not tell the difference between the Flutter app and the previous OEM Android app. Plus, you got your iOS app for free. So that's how great Flutter's performance is. You can really not tell the difference. Another interesting story related to this is that some developers asked the Google team that, can you tell me which apps on the Play Store are made using Flutter and which are OEM Android apps? The Flutter team raises their hands. They cannot do so because you simply cannot differentiate between both these apps because they look exactly the same. So let's get down to the real deal. So this is a simple UI. You have a navigation drawer on the left top that's represented by this hamburger icon. You have a toolbar that says Flutter. You have a menu action on the right that's an edit icon, and you have a floating action button. So any Android developers over here? Okay, could you please give me a guess how much time would this take on Android, building this on Android? Just the UI. 2 hours. Any other guesses? Sorry? 2-3 hours. Okay, so I asked a lot of Android developers. Some of them were really senior. I averaged out the time and I put it down as 30 minutes. Let's be fair to the Android developers. So React Native developers, how much time would this take on React Native? Any guesses? Let's say we are not using cool things like native base. If you're not using native base. If you're not using BuilderX. You cannot use anything that's developed internally at GeekyAnts. Let's go for 15, 20, 10. Okay, I averaged it out again and it came out to be 20. So let's say 15 so that all of you don't beat me up. So can you tell me or give a guess how much time would this take on Flutter? 10. Okay, so if we get this done in 10, would you be convinced to give Flutter a try? Okay, if we get this done in 7.5. Okay, let's get this done in 5 and let's see what the results are. So I came all prepared. I have a stopwatch that I'll be running really soon. So this is going to be a live coding thing and let's see how that goes. So before I start the time, I'll just walk you through what's there on the screen right now. I'm using IntelliJ. So for all Android developers who love Android Studio, try using IntelliJ for Flutter because it's lightweight and it gives you the same shot. So this is just a main.dart file that has a main method. Programming language, the main method is the starting point of your Dart program. I'm running an Android emulator over here. There's nothing on the screen right now. So I'll just go ahead and start the time. So just like main method is the starting point of your Dart program, I'll also be walking through every line of code that I do. The run app method is the starting point of your Flutter app and it requires a widget. So I cannot access the run app method right now because I need to import a package for that. That's called material. I have a stateless widget over here. I give it the same name that's in my main method. Yeah, so I'm a stateless widget. So there's a container, think of it as a parent layout. Let's just add a color to it so that we know that it really works. Right now I'll use this green button that's called hot restart. The yellow one over here is hot reload. I'm using hot restart for the first time because any changes that you make to the main method require you to give it a hot restart. After that you can use hot reload. So I just said 10 words and hot restart worked well. So I have a container that shows the blue color. I'll just replace this with the material app. The material app allows you to access components from material design, such as the app bar and all that. It lets you beautify your app. Let's remove the color. That requires a home widget. And let's just pass a scaffold over here. So the scaffold would really allow you to access the floating action button and the navigation door and all that stuff. So that requires a body. So let's just pass a container over here. Let's not make big changes. Let's give it a color. So I press hot reload in 3 seconds. 1, 2, 3. So it gets reflected in the app in 1.8 seconds. This would get better. So I have a scaffold over here and let's see if I can add an app bar or a toolbar. I try to give it a title. Let's just call it, and let's press hot reload. So you get a toolbar over here in seconds. Now I want to add a menu item on the right. So I have an icon button widget for that. That wants me to give it two things, an icon and an onPressed function. I'll just go with an icon right now. And let's just say icons.edit. I press hot reload. You can see the gray icon on the right top. It doesn't look so good. Let's just change its color. And I press hot reload again. It changes to white. Let's see if we can have a floating action button now. So I have a floating action button again. I'll just add a comma so that it formats well. That needs an icon. So let's use a favorite star icon for now. I press hot reload. Oh, there's an error. Floating action button dot extended should be there. So it's good that this came up because you have a crash in your app, the error is displayed on the screen, but you press hot reload, the error moves away, you get your floating action button back again. So this is how easy it is. Now let's just remove the color. Red looks ugly. Let's just remove this, press hot reload. Let's see how much time we have left. We are just over 3 minutes. Now comes the biggest challenge. You need to add a drawer in your app. The drawer is the toughest part in Android. I'm not sure how tough it is on using React Native. So let's see how tough that is using Flutter. So I just add a drawer, I press hot reload, and I have a drawer over here. And all this was done in 3 minutes and 37 seconds. Thank you. So that's how easy it is to pick up Flutter and build UIs that were a mess in Android or iOS. Plus, you get this on Android, you get the same thing on iOS as well. If I had an iOS emulator running over here, I would have got the same UI over there as well. So you get one app for free. So moving on, we did this in just over 3.5 minutes compared to 15 minutes with React Native or 10 minutes with React Native, whatever sails your boat. So even if the live coding part didn't work, I had backup. So this is a screenshot of the code that we just did. It takes 44 lines. The one that we did is 35 lines. If you format a code well, that would take 44 lines. So it's that easy to build this in Flutter. Have you ever seen a snippet of code that would fit in your emulator itself? You would never see this with Android. So that's how easy Flutter is. And Google had some tests run internally, and they figured out that building an app with Flutter is 1.8 times faster than building it with native Android. Just comparing it to native Android, we're not even talking about iOS right now. And again, you are using 50% lesser code if you are using Flutter and not OEM Android. Plus, you get your iOS app for free. So these are some of the benefits for Flutter. Let's come to the real deal. Let's compare Flutter and React Native. So Flutter is a mobile SDK from Google. React Native is a mobile SDK from, oh, sorry. I don't know how that came in here. They must be reading my slides and changed it, I guess. So React is a framework from Facebook. In Flutter, everything is a widget. In React Native, everything is a component. So let's see how is a widget different from a component. A Flutter widget structure is in Dart. The style is in Dart as well. The user interaction is handled by Dart. So everything is Dart. Pretty easy to use. A React Native component, on the other hand, the structure is in HTML, the style is in CSS, and the user interaction is in JavaScript. And this thing is called JSX. So for people like me who never really like JavaScript a lot, the full form of JSX would always mean JS extremely weird, just because I didn't understand it completely. So if you're using React Native as your primary mobile SDK, you may want to try out Flutter so that React Native becomes your ex-mobile SDK. So Flutter does not use OEM widgets. Everything is painted on the screen at runtime. React Native uses OEM widgets. Flutter offers 60 FPS jank-free animations. Animations on React Native do not have a wow factor. So if Flutter is so amazing, is Flutter the perfect mobile SDK to build your Android apps? Let's have a look at that as well. If you have an OEM iOS and Android app, the basic Hello World app that just has a text on the screen is a couple of MBs. The APK and IPA files is a few MBs, probably 1 to 2 on Android and a little more on iOS. If you have the same thing on Flutter, the basic app size is 6.7 MB. So let's see who the culprit is in this case. We talked, so there's another difference between Flutter and React Native, that Flutter ships a game engine with every app. React Native does not do so. Which engine is this that we're talking about? It's the same Skia engine that we talked about initially. That's responsible for approximately 4 MB of that 6.7 MB. This engine gets shipped with every APK or IPA file. This is the engine that we are talking about. But the good part is that the Flutter team says that they are not focusing, they are currently focusing on building a stable framework that offers a lot of features. They haven't even begun optimizing for size. So you can expect the size to be reduced later on after a couple of more preview releases and definitely before the stable release. So another thing that worries people about Flutter is feature completeness. Let's say there's a new feature in the market that's readily available on iOS and Android, but it's not available on Flutter because it's not using your native views. But the good part is that you can still hook your Flutter code with your platform code. How can you do that? If you see a Flutter project structure, there's a directory for Android and iOS as well. You can go into your Android code, access the main activity, activity main, all the files over there, and you can hook your platform specific code to your Flutter code itself. So every functionality that you have in your app right now can be done with Flutter by hooking it up with native components. So another thing is that I've already talked about this. If there's a new OS release, iOS 12 or Android P or something later than that, you get no new features on the OEM apps immediately. You can use those immediately, but you'll have to wait just a little while longer until someone or you itself creates a package for that. If you're really eager to try that out, you can hook it up with your platform code. And some people say that Flutter does not have a huge community. I don't agree with that. The Flutter community is growing rapidly. It's exploding in a way, and it could probably be the best ever because it provides you immediate support. So the Flutter community is big enough to have 32,983 stars on GitHub. This is from 1 PM this morning. I hope that by the end of this event, we reach 33,000 stars. So Flutter also has over 500 apps on the Google Play Store and many on the iOS App Store as well. This number is from a long time ago. This is not the latest number, but still there are a minimum of 500 apps on the Play Store. Let's do a small recap about Flutter. Flutter uses this amazing language called Dart that can be compiled or interpreted as well. Everything in Flutter is a widget drawn on the screen at runtime. Then Flutter offers stateful hot reload thanks to the just-in-time compilation offered by Dart. Flutter allows you to build high-quality native apps thanks to the ahead-of-time compilation offered by Dart. And you get the iOS app for free. All these features help you build your app in record time. When compared to iNic, Flutter does not use a web view. When compared to React Native, it does not use a JS bridge. It does not use a virtual machine in the release mode. And it does not have any access to your native OEM widgets. The best part is yet to come. The best part is that all of Flutter is open source. You can pick any bug, you can solve it, and it goes back into the Flutter code, and the community can use it. So Flutter's version right now is a release preview 1. There would be a couple of more release previews before the final 1.0 comes out. So if you're excited about Flutter and you want to start off with Flutter immediately, these are the resources that you can refer to. The best one are the Flutter docs. You head on to flutter.io, you see how you can build Flutter apps. There are 4 specific sections over there. One of them is Flutter for Android developers, Flutter for iOS developers, and Flutter for web developers. For an Android or iOS developer, you want to see what's the corresponding widget for a recycler view in Flutter, you can head on to that section. There's another section called Flutter for React Native developers. That's from the GeekyAnts team itself. So Google wanted to try that out because they knew that after hearing what Flutter is, a lot of React Native devs would be shifting from React Native to Flutter. That was explicitly meant to be there. I'm just kidding. Okay, then there's a resource that I started off my journey with. They are called the Google Code Labs. Really good, really detailed. You should definitely give this a try. If you're a blog reader or a person who likes to read a lot, you can subscribe to this Flutter weekly newsletter. You get an email in your inbox every week with the list of best blogs from the week itself. If you want to contribute to the community, write a blog of your own and submit it to the letter itself. Then there's this amazing YouTube channel called MTech Viral. The channel's owner is Pawan Kumar, who's the first Flutter GDE from India. He's right over here. If you could please raise your hand. So this channel has over 60 to 70 videos already on Flutter. So you should definitely try this out. If you're someone who doesn't want to compromise on the basics, you like learning from courses, Udacity being that famous, there's a course on Udacity, a free course from the Flutter team from Google itself. You can definitely try that out. Then if you're a podcast fan, there's a fragmented podcast from 2 Android developers who host a Google developer expert in their podcast, and they talk about Flutter for over 2 hours. Really interesting, do give that a shot. If you're looking for support and you don't find a lot on Stack Overflow, you can find that on Facebook in these 2 groups. Really good groups, you get support immediately. There are a lot of people already who have tried out Flutter over there. Then there's this Gitter chat. This chat has all the people from the Flutter Google team itself and the initial GDEs as well. So if you're looking for expert advice, you should definitely head down to this Gitter chat. If you're someone who loves learning in meetups or in groups, you should definitely contact your local GDG organizer so that you can ask them to organize a Flutter extended event or a Flutter Slams event. So I'll just wait for a couple of seconds so that you can. Okay, so even if you'd like to know more about the resources, I wrote a blog long time ago that has all these resources plus a couple of more. The URLs on the right top, so you can refer to that. There are 2 other blogs that I would highly recommend, both of them from Wim Lehler himself. He loves writing extensive blogs. The first one's called What's Revolutionary About Flutter. All of the queries that you have right now, most of them would be resolved using this blog itself. There's another one called Why Flutter Uses Dart, because a lot of people think Google introduces Kotlin, then they switch to Dart. What are they doing? So give this one a read and take out time because this is a 16-minute read. Previous one is a 15-minute read. So make sure you have ample time before you start moving on to this. So if you were sold on the idea of cross-platform framework already, I hope that now you're sold on the idea of Flutter itself. So using Flutter, you can finally say yes to your designer. So when you're using Flutter, your designer's happy, your developer's happy, your product manager, let's say some people are really hard to please. So I hope that all of you here at Flutter Bangalore are excited about Flutter and the community gets to see some really cool Flutter apps really soon. Thank you. Okay. So the major downside is the app size right now. The other thing is that when you want to use the components that are released with the latest iOS and Android updates, you'll have to wait a little while until someone comes out with a package for that. Probably these 2 are the major ones. No, it's just it's just with me. Yeah. Yeah, we have a question. Yeah. Yeah. So there's this layout inspector. Not sure I can't select it. So there's this layout inspector. Every view, every widget that you select over here, the same one gets highlighted in your screen in the emulator itself. You can use this. Yeah. Yeah, when you enable that using the developer options, the layout bounds method, you can see that. Okay, so that part you're using widgets that are drawn on the screen at runtime. So I'll put that over to Vim. Can we see the layout boundaries when? Okay, I think it's this. Okay. So I think you can do this using this tool, but not that layout inspector thing in the Android settings itself. Vim would be able to tell you better.
I think we can take it offline, no problem.
Yeah.
Okay. Any more questions on the generic side, on the architecture side, or anything else?
Sorry. State, yeah, you can use Redux, you can use scope model, and there's a blob pattern as well that you can use for state management. Yeah, BLOC. All right.
Yeah.
So he knows new ones as well. So you should talk to him after this talk. Sorry. Okay. So do we have support for libraries that?
How complete is the support of Google Maps?
Google Maps is not fully supported right now. It's supported. It's being used in the AppTree app, but it's not where the Flutter team would like it to be. Yeah.
So the native one is not supported, right? The native Google Maps? Right, okay. 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 Yeah, right. Mm-hmm. All right. Mm-hmm. Okay, so are we like rebuilding Google Maps in Flutter, or are we going to reuse the OEM widget which Google Maps comes with? Okay. Mm-hmm. All right. Okay. Makes sense. Yeah.
Yeah. So your Skia engine uses the GPU to draw everything on the screen.
Yeah, we have a question. Tanmay? Yeah.
Is there a GraphQL client for Flutter? A recommended one or a
That I'm not aware of. GraphQL client.
I've seen one. I've seen a GraphQL client.
open source one, but
Yes,
it's not
yeah.
as feature compatible as React, as Apollo?
show a little bit of that during my time as well.
All right, one small correction. React Native doesn't use HTML and CSS. It uses JavaScript in its like core. So there's no other language than JavaScript. We have JSX, which also compiles down to JavaScript. So just to put the correct information there. And I don't want this to turn into a religion sort of thing. People need to be, I think I'll just go there. I mean, everyone should be open to new technologies, and that's why we gave Flutter a try. And we shouldn't paint another technologies as negative ones, which is very important, I guess. So I guess when we are going to talk about Flutter, and you also, yeah. Okay. No, just, I mean, this is just a sentiment in the community that these two technologies are fighting against each other, which is not, which is actually, we are actually learning from each other. Flutter's core is actually based on React's architecture, which is like learning from each other, right? All right. All right. Anyway, we have a little break now. We have some refreshments available and some sort of networking. We'll meet here after 10 minutes, and then we can go ahead with Wim's talk. Okay. Thank you so much.
Test. Check 1 2. Hello. Test. Check. Check. Hello. Hello. Check 1 2. Testing. Hello. Check. Bertalo.
We have a couple of seats here. Yeah. All right. Over to Wim. Can we have a huge round of applause for him?
I can hear it, I think. Okay, so I'm Wim. I'm going to tell you, I'm going to actually repeat his talk word for word. No, I'm not. I'm going to try to do it differently, although there will be a little bit of overlap. So, title of this talk is Why You Should Try Flutter. And we have an ulterior motive with that, which is that when we have people try it, people are reluctant to try it because, they don't want to spend the time to learn new technology. But we find when people just try Flutter, like do some little project with it, just spend a day or two with it, that they fall in love with it. So we invite you to fall in love with it. So, whoa. First, I want to talk a little bit about Flutter and React. So this is the part that Sanket was trying to do for me. So the reactive parts of Flutter are very similar to React and React Native, okay? And we think, and I've used reactive systems for a while. Actually, interestingly enough, I used one called Mercury, which I think finally died, but it was actually a really nice one. So I've used a lot of different reactive systems in the past. But Flutter itself was heavily influenced by React, and to a lesser extent React Native, because React Native was just coming out then. And in fact, on our website, we say that Flutter was even inspired by React, okay? So we're not trying to bash React at all. We actually think it's kind of cool, which is why we were inspired by them. But, technology moves forward. So one of the things I'm going to try to talk about a little bit is what are the differences. And I think I have it turned off, but I have a slide at the end, if we have time, that even says why you shouldn't use Flutter, right? Just like you said. So, but I think you went through most of those things anyway. But beyond the reactive parts of it, Flutter is very different from React Native, right? So that's probably the things you want to know. If you're already using React Native, you want to know what's the benefit of switching over to Flutter, okay? So let's take a look. So if you go to the website, flutter.io, this is the first thing you see. It says, build beautiful native apps in record time. And a lot of people look at that and they go, what are you talking about? So let's break it down. We're going to do this in 4 sections. First one's build beautiful native apps in record time. And I'll go through each one of those. And Hopefully I'll be able to skip some of the slides because he already covered that material, but we'll see. So first one is build. So we're building mobile applications, right? Everybody knows that here. But I also want to point out that unlike most other systems, including React Native, it's a complete SDK. It has everything you need to build that app, right? We're using as little as possible from the platform. And so it's not just a framework. We usually don't call it a framework, we call it an SDK, but it's a full SDK. So in that way, it's very similar to game engines like Unity, right? When you're building something with Unity, you're not using native widgets, you're not using any of that stuff, right? So why are we doing that? Well, one of the goals when they started working on Flutter was they realized that the world changes quickly, right? So how long have you been able to write apps for mobile phones? What do you think? How long's it been? It's been actually just over 10 years. So 10 years ago, you couldn't do that, right? So in 10 years, the world changed dramatically. And we expect 10 years from now, the world's going to be completely different as well. And one of the things that we're pretty sure is going to happen is that there's going to be displays everywhere. I'm fully expecting that my shoes will have displays on them, right? I mean, there's already clothing that can display things. But, you know, even this is just I'm just showing the ones that are currently available. Some of you might recognize this one. That's the new Google Home that's coming out with a screen. It was announced a few weeks ago. We have thermostats. We have all sorts of things. We have smart TVs that have terrible user interfaces, right? That was one of the motivations also. It's like there's all these people that are going to put screens in everywhere. Oh, we also have cars, right? You know, the Tesla actually doesn't have that bad of a user interface, but it could be better, right? So people are going to be building lots of user interfaces for lots of different screens. And Flutter is designed so it can do all those things. That's one of the reasons why it renders all the way down, right? Because we don't want to be dependent on a specific kind of screen. We want to help everybody. But for now, we're focused on mobile apps, right? But I just wanted to point out there's this longer term vision of what we're trying to do with this. All right, so that's build. Beautiful. What do we mean by beautiful? Well, the way we like to say is no more cookie cutter apps. For a long time, when you built an app, it looked like every other iOS app or it looked like every other Android app. And that era is over. He showed some images with left-right images of award-winning apps from 2016. On all of those, one of the things that's consistent across all those apps that won awards and were very popular is that they used few or no built-in widgets. They used all custom widgets. So the Flutter developers realized that customized widgets were the future. You know, like it's not good enough just to write an app anymore. You have to write an app that stands out, and the way you do that is with custom user interfaces, right? So you want to be brand driven. You want the app to reflect your company, not Apple or Google, right? And we want you to be able to do that. So highly customized, and as he said very well, you want to be able to say yes to your designer. You never want to have to say no, right? And yet, you still need to be able to have the app be usable, right? So there are differences between iOS and Android that are important, and you want it to feel like that. And that doesn't mean you want different design. It just means you want that functionality, that ability to control the app to be the same, right? So that people can use it. And I think of that as like automobiles, right? There are all kinds of automobiles. You have sports cars, you have trucks, you have, you know, you name it. And yet every one of those things, the steering wheel does the same thing, right? You push on the gas pedal to go. It's in the same position on every car. There's a brake pedal next to it. Used to be a clutch pedal, gone. Well, no, you have clutch pedals here, that's right. We don't have them in the US anymore. I don't know why. It's very hard to find one. So the idea is you can get into any car and you'll know how to operate it more or less, right? But all those cars look completely different. They all have, they have their own style. You know, a Ferrari is always going to look like a Ferrari. It's not going to look like a Volkswagen, right? So that's what we're shooting for. We want to be able to have that user interface that feels familiar so you can use it, but then we want the design to be up to you. And last, but not least, we want these apps to be smooth. You know, a lot of people talk about app speed. What we found is that the speed of the app is actually not the important thing. It's how smooth it is. And if an app is going, you know, really fast and then it hits a garbage collection cycle and it jerks and stuff like that, doesn't matter how fast the app is, it looks terrible, right? And that's what people notice. They get used to speed really fast. You know, it's like, how many people have gotten a new phone and go, wow, this is really fast, and then 2 weeks later you're like, still waiting for it, right? You get really spoiled quickly. So speed is not the answer. That's like, you know, drugs. You get addicted to it, right? But smoothness is the important thing. So, beautiful apps. These are 3 apps that have been released on Flutter in the last few months. The one on the left is, I think, the newest one. It's from Abbey Road. Does anybody not know who Abbey Road is? Okay, Abbey Road is the music studio in London that produced, I think, every Beatles album, and about half the really great albums that ever came out of England. It's a fantastic studio. There's actually, this is a total aside, but Google built a street view tour of the Abbey Road studios, so you can actually walk around inside of it, and they'll actually have bands, you know, standing there, and you can walk around while they're, you know, frozen, not practicing and stuff, and they have videos and stuff. That's a really fun thing. Anyway, they came out with an app that's a recording studio, right? It's a very complex app. It uses all sorts of things. They did it in Flutter. The next one is Alibaba. I love this one because you look at this, it doesn't look like an app at all, right? It's actually really beautiful, but it fits their style, right? No native widgets at all. Of course, we don't use any native widgets, but it doesn't look like the native widget. And then this last one, this is something up until about, I don't know, 5 or 6 months ago, we were telling people, don't build games with Flutter, you know, because we're not focusing on that. Well, these guys ignored us, and they built a game engine that runs in Flutter. It's called 2 Dimensions. You can actually download this app, and I recommend you do, because I'm actually only showing you the least interesting game there. They have 3 demos you can see down here, demo 1, 2, and 3. This one you can play with. The second one is actually even more impressive. It has a real-time animation going on. And one thing, if you do download and look at it, you'll notice something interesting about it. The thing that shows the widget that shows the 3 different demos, it's actually transparent with a real-time animation going on behind it. And as far as we know, nobody else can do that, only Flutter. Right? That's a hard thing to do. And then the third one's actually a game you can play, so that's worth downloading it anyway, and it's free. So anyway, the whole point of this is, look at these 3 apps. Can you actually believe that they were all written by the same framework or the same SDK? They're really different. And that's the important thing. We don't want cookie cutter apps. We want apps that are designed for their purpose. And there's more of them. I'm only showing a few of these. In fact, we don't have a lot of time. I'll probably just mention, you know, but you can see they're all very different, have different styles. The last one is a chat app, yet another chat app, right? But you can only send and receive emojis, right? So it's a chat app for children, and it even has parental controls on it, so you can, you know, control who they're chatting with and stuff like that. Anyway, just a brilliant thing, real easy to do in Flutter. Okay, so that's build beautiful. The third thing is, what are we building? We're building native apps. And he already gave away the punchline of this, but I just want to talk about what does the word native mean, because it's a word that's abused a lot. Most people think that native is the OEM platform. And again, Rowan mentioned that we like to call it OEM because, you know, it's kind of an error to call it native. But we also have the word native used a lot by like React Native in Xamarin Native. So they're talking about the native widgets or the built-in widgets on the platform. But if you actually look up the definition of what native means, even in the computing world, what native actually means is something that's written in the language for the processor that it's running on, right? So this is from the Oxford English Dictionary. So by definition, what Flutter's doing is native. As he said, we are compiling all the way down to ARM code. It's raw, right to the metal ARM code. We're doing the same thing for the GPU. We're emitting stuff where there's no virtual machine. So we're actually more native than Android. Like, that's pretty crazy. And we don't use JavaScript, right? Which is like what React Native uses. Actually, every cross-platform tool other than Xamarin probably, I think, uses JavaScript. Are there any exceptions? I'm just thinking that. I might be wrong. Anyway, so apps are native on each platform. One of the nice things about being native is that you have a lot of control over the execution. So it's not that Flutter is incapable of writing jerky animations, but if you see that, you can go in as the developer and fix it because you have control over it, right? Unlike in JavaScript or something where a garbage collection can happen and you have no control over it, right? So that's a thing. And as I said before, this is like game engines like Unity. You know, Unity compiles down to native code as well. All right, so, and in fact, Flutter is the only reactive SDK that is native, right? So that alone should make it worth your while to try it out. You know? I mean, how many people here like using JavaScript for writing their large apps? Okay, I do too, actually, okay? I'm one of those people. I like JavaScript for some things, but there's other apps that it's just the wrong language, right? And as Sanket and I were talking about, use the right tool for the job. So yeah, if you're building, there's a lot of apps you can build in React Native, great, build them in React Native. And then there's a lot of apps where you actually want a strongly typed language. You don't want any errors, right? I mean, we all know the difference between, you know, dynamic and static languages, and they have different purposes, okay? So reactive in Flutter, we have reactive views. Just, you know, they're very similar to the ones in React Native. So if you're coming from React Native, you'll feel very comfortable. We even have some of the same function names like set state and stuff like that, right? But we don't have a JavaScript bridge, which is another thing that causes speed problems in React Native. Another thing is, and I'll talk about this later, we only re-render what has changed. So when we're doing animations, and there's a lot of animation going on in Flutter, we actually only repaint those parts of the screen that have changed. And that speeds things up dramatically. And in fact, that's so fast that we have no support for scrolling. Like almost all frameworks, you have special code just for doing scrolling. Right? Because scrolling has to be really fast. I mean, if you're scrolling and you know you want as your finger moves, you want it to feel like that screen is attached to your finger. And if it's not, you get kind of seasick, right? So that's really important. In Flutter, scrolling is done by layout. Okay? And earlier, I think I had an image of this. Now I can't even remember where it was. This one. Okay. If you look closely at this, watch when it gets back to the main screen on this one. Watch as it scrolls. You notice some things are moving sideways, things are moving all over the place. And it's as fast as scrolling. So you can do any kind of scrolling you want. Now, I don't know why you'd want to do crazy scrolling, but if you do, you can do it in Flutter. You know, the whole point is you can do anything you want. And in this case, it's actually kind of cool looking, right? Anyway, way too many, far back. Okay, so also Dart has streams built into it. They're not quite as capable as the ones in ReactiveX, but there is a version. There's RxDart, so you can have full ReactiveX streams, but you don't need them most of the time. You can just use the built-in streams. So it's designed to be reactive. And of course, the other thing that we get from reactive is we get the stateful hot reload, because that keeps the state of your view separate from the actual code. And that's what allows us to keep hot reload being stateful. All right, so quick, and yet another diagram. Here's React Native. So the way React Native works is you have your app and you have a virtual tree of widgets, right? That's built inside that. And if you have an animation or anything else going on, it keeps track of what's changing. And it updates the platform's OEM widgets, right? So there's this, excuse me. All right, so there's two stages for rendering. You go through this thing where it does a comparison, it updates the native widgets or the OEM widgets, and then those widgets are rendered on the platform, right? And Flutter, as I already gave away, skips that entirely. Now that widget tree is the only tree of widgets. It is the widget tree, and it's rendered directly to the canvas, right? So that's another way that we get a lot of speed and a lot of control also, because anything on this left side is in your app, you can change it. Okay, so he's already gone through this, but I just wanted to point out that, the Dart framework is actually more than that, because not only does it include the framework, the reactive parts, but it includes all the renderers. In fact, it has the gestures in it. You can add new gestures to Flutter. It's actually really easy to do that. I've done it. Okay, and you can add new types of animation. And then it has all the widgets. They come with it, right? And then underneath that is the engine. He's already talked about that. I'll skip that. Okay, fourth and last, you can do all this in record time. And I'm going to give you lots of examples of it. And the first example is hot reload. You already saw him doing hot reload. Everybody believes it's fast, right? Great, okay. Going on. But hot reload is only one part of that story. Okay, another area which we think actually has a bigger impact on being able to get apps out is in testing and maintenance, right? So what we're showing here, this crazy guy is looking at a phone. This is a phone running Jelly Bean, right? Jelly Bean came out in 2012, and Material Design, as he mentioned, came out 2 years later. So this phone has no capability of showing a Material Design app. So if you wrote an app and you're using Material Design, it's not going to run on that, or you'll have to use a compatibility library. How many people like compatibility libraries? Not me. No hands. Wow, pretty good. But this app looks the same on this 2012 phone as it looks on the current phones, right? So you know that when you create an app, it's going to look, what it's going to look like on every phone that it will run on. So no longer do you have to buy 15 phones and test your app out on every version of that operating system. And then you have to do that for 2 platforms, right? You don't have to do that anymore. You're creating one app and it's going to look the same. You know what it's going to look like. And that means that you also don't have to do all that testing on different platforms, right? You only need to test on one platform each. So that helps a lot. You can be assured that things are going to work. So how is this possible? Again, as I said, the Flutter app is rendering directly. It's using its own widgets. It's controlling every pixel on that screen, which means you're controlling every pixel on that screen, because you can write the code to change any pixel on the screen, right? And no need for compatibility libraries. New OS releases come out, they don't break your app. So not only are you backward compatible, you're forward compatible. As long as they still allow you to write to the canvas, your app is going to run, and it's going to look good. Now, if you want a new feature, you know, let's say a new phone comes out and has a new feature and you want to take advantage of it, what do you have to do then? Well, you just download the latest version of Flutter, recompile, and you're done, and you're going to take advantage of that, right? Because that's built in. So new features run on older phones, and you can take advantage of new features. And in fact, when you do that, since you have the new version of Flutter, it will have that new feature on every old platform as well. This is really awesome. Right? This makes a huge difference. So an example of this is when the iPhone X came out. And everybody was surprised when it came out because it had this weird notch at the top, right? Flutter actually supported the notch before Apple did. You could actually write an app in Flutter before the phone came out, right? So we were the first platform to support that because it's really easy to add. And you could run it on the simulator and test it and everything and release it and support the notch. Now, that's not a case of backward compatibility because there were no phones backward that needed a notch, right? But at least, you know, your app, if you just recompiled with the latest version of Flutter, would work with the notch. So you don't have to go through and like relay out your app because you have this weird layout now. It just works. Okay, internal results. I'll go through this really quickly because Rowan went through this one as well. So this was an experiment that was done 2 years ago. This is before we went alpha. They had this internal app. They wanted to convert it to iOS, and they were about to hire a bunch of iOS developers because we don't have a lot of iOS developers hanging around inside Google. I have no idea why. And the results were, and so when they decided to do this, they said, okay, we're going to measure this. We want to see whether this is faster or not. And it was faster. It was less code. And the other thing they found was that as they hired new programmers, they could actually bring programmers up to speed on Flutter faster than on Android, okay? And they had faster development cycles. They could add new features quickly, and maintenance was easier because they only had to worry about one set of tests, one platform, and the testing didn't have to be done for any change they did, right? So that's just compared to writing one platform app. And then on top of that, as he said, you get iOS for free, right? So, and he also mentioned later on, this is great, so they rewrote an existing Android app into Flutter, and they released that, and they didn't tell anybody that they changed anything, and nobody noticed. It looked just like the Android app. And on iOS, it looked like an iOS app. It had the different scroll, and you have different icons, different fonts, everything. So it was a big success. And this is before we even went alpha. And that's about the time that we realized, oh my God, we're onto something. So Hamilton, you mentioned Hamilton. No, you didn't mention Hamilton. Okay, so let me talk a little about Hamilton. You've probably never heard of Hamilton. It's the most popular musical that's ever been on Broadway. And it's pretty hilarious because it's a musical about the Revolutionary War in America, and it's done in hip hop. Okay, so it's a wild and crazy play, but it's been wildly successful. I've never seen it because, the tickets are all scalped for about $8,000 each, and I don't have that kind of money. But they decided, it was so popular, tickets were actually sold out a year ahead of time on it, that they wanted to create an app. And one of the things they wanted to do on the app was to have a lottery. You enter the lottery, and it's not really a lottery because you don't pay for this, you just enter it. And every day they pick somebody and they give them a $10 ticket. So they can then go see the show for $10. Right? And that's because, they were trying to be revolutionary and they wanted everybody to be able to see it. And, at $8,000, a lot of people couldn't go see it. So they wanted to have an app and they wanted to have a bunch of other things. So these people found out about Flutter at Google I/O in 2017. And they went back and in 3 months, they wrote an app which was featured on both iOS and Android. So, and it's very popular. And it's a fairly complex app. In addition to the lottery, which you have a couple of screens here of that, there's a camera for doing selfies, and you can like put yourself on the dollar bill, or you can put King George's crown on your head, or put a ball gown on and dress up and stuff like that. So it's kind of cute. They also have a store for selling merchandise. They have interviews. They have all sorts of stuff. And so the bigger thing, though, is that this app has remained popular. And the reason it remains so popular, that's not me beeping at it, is that they continuously add new features to it. So they have 500,000 monthly active users for one play, right? That's pretty phenomenal. And those people come back all the time because they know there's going to be new content. Right? So let's go to another example. This is a company actually in Portland where I live called AppTree. You've never heard of them. You never will hear about them other than here. But they have a lot of big name customers. McDonald's. They actually have about a dozen universities that I know of. One of them is Stanford, Fermilab, other places like this. So they're building enterprise apps for these customers. So for example, at universities, if they build apps that help you, okay, if the heating fails in one of your buildings, where's the valve to turn it off and work on it, right? Things like that. So this is the app I was talking about. They're heavily dependent on maps, but they also need them to work offline. So their whole app works with or without internet connectivity, and they're large apps, okay? So they ran into a problem in 2017. They actually were so successful, they had so many clients that they were a year behind adding new features. Because not only did they have an OEM Android app and an OEM iOS app, they had a web app also. And so any new feature they added, they had to add to all three platforms, and they had to look alike. And they're a small company, right? So they were in trouble. They could not add features. They were falling more behind. And they found out about Flutter, actually in August of 2017. And they decided to do a trial. They said, okay, for 6 weeks, we're going to try to rewrite our app in Flutter. And after 3 weeks, they had they had a minimal MVP, a minimum viable product running. So in half the time they allocated for it. And so at that point, they threw away both of their OEM apps and rewrote the whole thing in Flutter. And they have an article, and I strongly recommend you read this if you're interested. It says, the article's title is Why We Chose Flutter and How It Changed Our Company for the Better. Right? It changed their company completely. They can now add features much more quickly. They say that they have a 3x productivity gain. Right? And at the end of the article, the last line is, mobile development is fun again. And this is something that we hear from people all over the time, and I want to point out how important this is. One of the things that's really nice about Flutter is that it removes a lot of the drudgery. What's the fun part about mobile development? Adding a new feature. What's not fun? Replicating it on multiple platforms. Testing it on even more platforms. Fixing bugs. Having 2 separate teams that implement the same feature, but it's different enough that it confuses people when they switch between the web and iOS or whatever, right? Those are the not fun parts. They don't have to worry about that stuff anymore, right? So it's fun again. So GeekyAnts, I had to put in a quote from GeekyAnts. Actually, I've been using this for a while. I didn't put it in for this one, but they're fans as well. And Alibaba. This one's made a huge difference to us, which really surprised us. Alibaba came out with an app that uses Flutter. And this is actually just a couple of weeks old, these quotes. They sent us a bunch of quotes. So we got quotes from about I think almost a dozen different engineers and managers inside their company. And they said that it significantly reduces the amount of time to add a new feature. It used to take them a month to add a new feature. Now they can do it in 2 weeks. All right, so a little bit better than 2x. We're adding new features. So an incredible efficiency boost. And they have more. They have there's like 2 pages full of these quotes, and I only picked out a few of them. They talk about Flutter running in native mode. It's very flexible, so they can do things that it was hard to do before. It's very smooth, especially on older devices, because we're doing the rendering ourselves and we're not depending on that device. And they also mentioned that it reduces the time to test. So I'm wrapping up a little bit, although I haven't done the live coding yet. Why try Flutter? You can write things faster. It's high velocity development. It's a very expressive and flexible toolkit, and it produces native apps. Those are the reasons to try it. So let's see a demo. So what I'm going to do is, he did a really good job of showing you hot reload, so I'm not going to do so much of that one, but I am going to do part of my demo, and that is he took the existing web widgets that come with Flutter, and he built something really fast. I'm going to build a new widget. All right? So let's see if I can do this. So the way widgets work in Flutter is that they use composition. We don't use inheritance for defining, chains of widgets. And so a floating action button, nice simple widget, it's actually quite complex. It has the little ink splash, when you click on it, it does a little animation and stuff like that. We can build our own. So that's what I'm going to do. I'm going to duplicate a floating action button. Build it from scratch. And so a floating action button then uses 3 child widgets. So the top level one is material. So a material widget defines how it looks. And then underneath that is a container, and that's what controls how big it is and other aspects of it, padding and stuff. And then the inkwell is what does the ink splash and controls the interaction. So let's do it. All right, so you've already seen that sort of stuff. Yeah, let's just, actually, let me fix one thing that I always hate. So, it has this thing where it shows you push the button this many times. Let's just get rid of that. So I'm going to delete that widget. And then I'm going to just put it into here and call it count. All right. I can save it, and that's what it looks like now. Now, one of the things you might notice is before this was a column, right? Because it had two texts in it. We want to get rid of the column. Let's go back to that outline that he sort of. So if I click on the column, so that column's right there. So when you highlight something in the text view or in the code view, it gets highlighted here. And then I can just say, okay, get rid of it. It's gone. Okay, so really simple. So this is sort of the poor man's graphical view. It's showing the widget hierarchy. You can manipulate it really easily. Okay? And we can do a save, and there'll be no changes. We just got rid of something we didn't need anymore. So let's, yeah, let me add a few more floating action buttons. Okay, so down at the bottom we have a floating action button. And let's go ahead and put a column in there, because now we want to have multiple floating action buttons, right? So we can do that from the outline view as well. We have the floating action button, we say put it into a column. All right, so now we have a column. See that code? Yeah. And I can save it again. And what happened? You know what happened? We have a column, and the columns always start all the way at the top. So our floating action button actually is way up in the upper right corner. So let's fix that. Let's make that be a main axis alignment is okay, back where it belongs. Okay. So that's all the work to do that. Now let's add some more floating action buttons. So I'll grab one of the one floating action button. and save it. And now we have two floating action buttons. Okay, I haven't built a new widget yet. I'll get to that in a minute. But let's make this a little bit better. Let's put in some spacing. So size box. I'll say I'm not nearly as fast a typer as Rowan is. Okay, so I'll put that there just so it's spaced apart. So I kind of cheated here. The way I put spacing around it is I just put a little blank box in between them. You could have also put padding around them. Right? That would work as well. But this is nicer. So in this case. So we have two floating action buttons, and they look and do exactly the same thing. So let's fix it. Let's change the icon to remove. You can see it now it's a minus. And let's add some color. So that one's now green. And let's change the other. Oh, let's just cut and paste, make it life easier. Okay, so now they're different colors. All right, so now I'm going to get to the fun part. We're using built-in floating action buttons here, just like he did. But just below it, I've already typed in a definition of a new floating action button. This one's called myFab. Right, so I can go through the code here. This is just the signature of the constructor. We have 3 local variables, and then we have a build function. Build function is the interesting part. And as I said before, you have a material widget, which has a child, which is an inkwell, which has a child that's a container. All right, so this is there. So I can just go up here and I can change one of these. Oops. I can say this is a myFab. Let's save it. And nothing changed, right? It looks exactly the same. And you may not believe that we've actually changed it, but we have. So those 2 different fabs are being drawn by completely different code, one that I just wrote, right? And it still looks the same. So, but if you're going to build your own floating action button, you probably want to change something about it, right? So let's do that. Let's go back down here and say, you know what? My designer came to me and he said, yeah, you have those floating action buttons and they're all circular and I hate them. I want square floating action buttons, right? That would be hard to do if you're using a native widget because you can't change the native widgets. Or excuse me, I keep saying native. I'm such a bad boy. So let's put in a button material and save it. Now we have that. Now, how many people noticed the animation? Did anybody notice that? Okay, a couple people in the front row. Let's do that again. So we'll go back to being a circle. Watch that top floating action button. When it changes from a square to a circle, it doesn't just change, it animates between them. Did you see it? Okay, and then we can change it back to be a button. And I'm just going to do it one last time. Ready? There. Okay. No, the reason I'm showing this off is that there's all this animation inside Flutter that comes for free, right? The container widget, if you change its shape, it actually animates between them for you. And animations are really important in mobile apps because they help direct your eye to what's going on, right? And this is something you get for free. This is one of the reasons, I mean, this is just a simple animation of one object, but let's say you have an object that's coming on screen or something like that. That animation will look really nice and you can control it if you don't like the default, right? Like we could even change, you know, how fast that animation happens. That'd be kind of silly to do on something as small as this, but you control that animation a lot and you can have things animate in and out really nicely. And if you're trying to use a static layout tool, it's kind of hard to control that animation. So right now we're focused on making the code be as easy to build, you know, to use as possible so that you can control the animation, the layout, everything all at once. Okay, so, and you show this to the developer, and they say, well, that's nice, but I actually want rounded corners. So we can say border radius is, oops. One, and we'll say 10, I guess. Okay, so now we have rounded corners. And that animated too, but you didn't see it because it's so small. Right? So let's go back up here. And so we have one fab and one floating action button. You can see they're different. We can just change the other one as well. So we can say my fab, save that, and now they're both easy. And it animated as well. All right, so we just changed that. And then the developer comes back and they say, column looks kind of weird and it's taking up some of my real estate. So can we do this as a row? And you say, what else would you like me to do? Right? And there's a lot of things like that. Like in CSS, if you want to center something, there's like 8 different ways to center something, and you have to know the right one for each thing, right? In Flutter, there's one thing. It's called center, right? There's one right there. Oops, right there. And it will center whatever the child is. Doesn't matter what it is. So you say center, and it centers. Don't have to worry about that. That's because the way Flutter does layout is very different, and I don't have really time to talk about that. Anyway, we can do more stuff. We can add another button. Actually, let me do that as one last thing. So we'll create one more floating action button. I just realized that I didn't do something. Did anybody realize what I missed doing? What? Exactly. So the counter before was being incremented, and I want to change that to be decrement. And as soon as I do, oops, I already added that other one. We'll fix that later, but let me just show you these now. They actually still work. You can count up, you can count down, all that stuff. But we're going to change this one to be a reset. So, and let's change it to be, let's change this one to be orange. So we have like a traffic light or something. Okay, so now we have 3 of them up. We're using the wrong icon. Instead of remove, let's make it replay. So there. And our designer is happy. Right? So that's how you can build stuff like it. And if they might look at this and they go, that red is a little bit too light. Can you make it a darker color of red? And you can go, sure. So there. Another thing I suggest you look at is the new material design, which has theming. They came out with a whole bunch of tools that are really nice. And Flutter is actually the only SDK, and that I'm including Android, iOS, and web. We're the only one that fully implements material design. And we fully implemented it before they released it. Okay. So instead of actually dragging behind the OEM platforms, we're often ahead of them. Okay. For the notch, for material design, whatever. And the new material design is really, really nice. You can actually create very strange things. I mean, you can do stuff like, oh God, here, let me just do one quickly. So instead of having a circular border radius, we can say only, and then we have to say we're going to do something in the top left. Well, if I wasn't destroying my thing. Let's move over a little bit. I think that's right. Nope. What I do, closing paren. It's even telling me that. Okay, so that's actually too small. Let me make it really obnoxious. So this is like you have a new age designer comes in. You know, we want really weird looking buttons. I've actually seen things like this in use, so don't laugh too much. Anyway, you can just, what I'm trying to show to you is not only can you do anything you want, it's really easy to do anything you want. We built a brand new widget. It's a fab. Fab is rather complex, and yet we're able to do it because it builds on top of other widgets. We can go in and change those other widgets as well if we want to. We can replace them. We can do anything we want. It's pretty fast, and the hot reload means you can look at it and, you know, say, nah, that's not really what I wanted. You know, you don't spend like 2 weeks implementing a button that looks like this and just have the designer go, nah, right? Anyway, so back here, you know, this is what I was showing, that the container, so these three things are just widgets. One nice thing about the container is, you know, in CSS you have margin and you have padding and they're different. They're the same thing, and we just have one padding widget, and it can either be inside the widget or outside the widget, and it just works. So you only have to have one widget for doing padding. There's the code. There's the change to get the rounded corners. And if you want more info, I think he had a good slide, but you can see this one also, and I'm hawking my own articles as well. So thank you. So anybody have any questions?
I have one thing that I want to ask. That code, right? Alan, like N. Is it possible to do for each children, Alan? For example, you made the big, all the like things down, right? Is it possible to do one at the top and one at the bottom?
Oh yeah, of course. Yeah. You can. There's built-in ones, so you can say center. You can say beginning, end. Actually, I think it's start. You know, I never remember the actual ones because the code completion just tells me what it is. But you can also like say spread, so that they're spread evenly, or you can have it where the first one's at the top, the second one's right in the middle, and the third one's at the bottom. There's all sorts of built-in things. But if those aren't what you want, don't use that. Instead, just position them yourself, right? You can position in terms of percentages and stuff like that. So pretty much anything you want to be able to do, you can do with it. Right? And right. And if it doesn't do something that you want it to do, which I'm not sure if that is true, you could write your own one, right? Or you can go in and you can modify the existing one. I mean, one of the nice things about this, if I go back to this one, if you've done, well, I don't have a floating action button anymore, but I don't know. If you want to see what the material widget does, you can just do that. And I've just opened up the source code for the material widget, and you can look at it and say, oh, that's what it does. And you can modify it if you want. I'm not sure if I recommend that because you're you're basically forking Flutter. But what you would more likely do is you just copy it, give it a different name like my material, and change it any way you want. Right? So you can modify any of these things. It's just they're all there. Right? How much time do we have for questions? I don't want to drag on.
I think we have like 5 more minutes max.
Okay.
We have like one last talk after this.
So, and I promise you, after we're all done, I'm not going anywhere for a few minutes. So if you want to ask me questions.
I think we have one last question. Yeah.
Yeah. Right. Yeah, no, that's really easy to do. You have full access to all the information about the platform you're running on. So you can, you can just say platform.ios equals true, do one thing and do something else on every other platform. You can also even tell which version of the operating system it's on. You can tell how big the screen is. You can find out almost anything you want, because more common than wanting to do something like that is like, okay, this phone has a bigger screen, so You figure that out and you want to do the layout slightly different for that. Yeah, you can do all that. That's all manual stuff, right? But if you've done your layout properly, you know, where you've used things like the one that spreads things out across an area, you can actually make the layout so that they automatically adapt to it. Right? Uh-huh. Anywhere you want. You can do it at the top level and have two different things, or you can actually just have a different widget on them, or I mean, it's code. You can do anything you want. I mean, there's not any way you have to do it. You know, I mean, you could sit there and just say, okay, if I'm on iOS, use the built-in floating action button, and if I'm on Android, use MyFab, and have them be completely different. But I also want to just say, don't do that, right? We don't want to make apps that are different on different platforms, because then when somebody picks up their wife's phone and tries to use the same app, you know, it's surprising to them, right? All those award-winning apps that he showed, and I can show even more of them, they look pretty much the same on both iOS and Android. And those are the apps that are popular and win awards. So why would you want to do something different, right? Okay, you can do it. I'm just telling you, yes, if you have a crazy client, and I'm sure all of us do, right? Then, you know, you can do stuff like that. I mean, I didn't really show the Hamilton app very much, but did you notice that they didn't use any of the built-in icons? Like, they didn't use the normal menu icon. They changed all this stuff because they didn't want it to look like anything. They wanted it to be wild and crazy, right? So they were able to change everything about it. Now, they wanted them to be the same on both platforms, but you can easily do that, and you can test for any characteristic of it and just say, yeah, if it's on this, do that, okay? The other thing you can do, we have an app called the Flutter Gallery, which I recommend that you download and install. And if you pull out the drawer, you can let's say you're running it on an Android phone. You can open the drawer, and one of the options is what platform it thinks it's running on. So you can tell it, okay, you're actually an iOS phone, even though you think you're an Android phone, right? And it does the scrolling the other way. The scrolling thing is a hilarious story, actually. When they first were doing Flutter, they wanted to get the feel of scrolling just right, you know, because that's really important. And the scrolling on iOS has a very specific behavior, and it's very different than the scrolling on Android. And people, they don't really notice it. I mean, they don't realize it. But if it's wrong, then they really notice it. It's bad. So they actually got a phone, they drew a grid on it, and they got a really high-speed camera, super high-speed camera. And they did the scrolling, and they filmed it. And then they took all the coordinates of, you know, like, okay, over time, you know, how fast does it accelerate, how fast does it, you know, all this stuff. They put all those data points, and they fed them into Wolfram Alpha. And they got out this really simple polynomial, right? And, you know, most of the time when people do scrolling, they do this big physical simulation, right? That is modeling acceleration and deceleration and the mass of the screen and all this stuff. Anyway, they ended up actually with a faster implementation of iOS scrolling than iOS had. And then they went ahead and did the same thing for Android, because they decided, oh, we shouldn't use the physical simulation for Android, we can do a really fast one. And that's how, you know, scrolling came about. So when you're doing those things, we wanted it to look exactly right. We were surprised that we actually got a better implementation. So I think that's it for questions.
Yeah, I think we're running out of time, so you can take these questions offline, no problem.
Yeah,
all right?
I'll be happy to hang out as long as you want. And I also just want to point out, I brought this and I gave it to Sankit.
Yeah, thanks
It's
a lot.
my last one, because I filled my suitcase with these things.
Thank you so much.
But
all right, thanks a lot for flying all the way from Portland.
My pleasure.
All right, so we have one last talk, which is actually common to React Native and Flutter devs. It is not specific to that. And we have Tanmay, who is the CTO of Hasura. Hasura, I think he can talk about that, what that is. Last week he was in the Valley talking about Hasura to the people in the Silicon Valley, and he's here again today. So please give him a huge round of applause here. So actually, yesterday I saw a tweet on Twitter which says there's a place for REST and there's a place for GraphQL. The place for REST is in 2004. uh, anyway, I think GraphQL is the way to build APIs of the future. And Hasura is doing a great job in that. I mean, it's like Firebase, but for GraphQL, right? Okay. All right, I'll let you continue. Thank you.
What we are doing is we give you instant GraphQL on Postgres. So on new databases or on existing databases that you have, today Postgres, tomorrow maybe other databases as well. Just before I start, how many of you have heard of GraphQL? Or how many of you have used GraphQL? Okay, how many of, so what does, for those of you who have used GraphQL, what does your GraphQL backend stack look like? It's like a shout would do. What does your GraphQL backend look like? No? No answers? Node.js? Mongo? Sorry? MySQL Node.js? Alright, awesome. Anything else? GraphQL, awesome. Sorry? I didn't catch that. Okay, cool, doesn't matter. Alright. So, my name is Tanmay and I'm super happy to be here today. Mostly because I'm extremely happy to be part of the community that is such a big part of the open source ecosystem with dev tools that are coming out of India. This is a new version of Java. No, so this is, it's really nice, especially with native base and BuilderX and Vue Native coming out from here. And so I'm very excited to kind of introduce our GraphQL engine on Postgres. We launched early this week on Monday, and we were GitHub trending globally for the early part of the week. Great early reception from the community. What I'm going to do is I'm going to zoom into like a super fast demo to take you through a bunch of use cases and then take your questions. I'll try to keep it around 15 minutes and then for questions. The question that we wanted to answer here is what is the fastest and simplest way of getting a GraphQL backend backed by an open source database, right? Not locked into something that you can't see. So, and also so that you don't lose the underlying database's power, which often happens when you have a layer on top. So, I'm going to do a live demo and we shall pray to the demo gods to see if everything goes okay, right? So, let me just load up Firefox. Cool. So, I'm going to do this deployment on Heroku. And so, I'm going to use Heroku's free Postgres and React Native Flutter Bangalore Meetup. All right, and we'll set this to Europe. Sure. So this is now taking the GraphQL engine, which is a Docker container, and it's using Heroku's Postgres, which gives you 10,000 rows for free. And then it's kind of connecting to the database automatically because Heroku lets you do that. And then we're deploying it there. It's a tiny Docker image, so it doesn't take too long to deploy. It's a 15 MB Docker image, super lightweight. And as soon as it's ready, you can see that it gives you a fingers. All right, cool.
How do you compare with PostgreSQL file? Okay, one follow-up question. Do you have a subscription on this thing? Like the live subscription of GraphQL? Do we have support? On Hasura? Okay, no problem, yeah. Okay. Okay. Okay, because we had some experience with GraphQL and the subscription didn't really work well. So we are looking for options, and Hasura is definitely the like the topmost. Okay, interesting. All right, so that was the last talk of the evening. We've got pizzas and some beer and Coke available outside. So feel free to grab that, and you can chat and network and ask questions from the speakers. Thank you so much for coming in.